course. In this lesson, we will be studying integration techniques, which is partial fractions, right? So in the previous lesson, we have done all the rules of decomposing a partial fraction, decomposing the algebraic fraction into partial fractions. Now, let us solve some integral problems involving partial fractions. So we're going to look at the first types of looking at examples. So I've categorized them. I said it's linear factors. So we want to integrate something like this. Now, remember, before we integrate something like this, we need to know like the general form of integrals. What's the integral of 1 over a linear factor? Example, 1 over mx plus c or mx plus b. 1 over mx plus b dx. So the integral of this will be obviously len form, len absolute value of mx plus b, right? And you will have a 1 over m on the outside, okay? 1 over m, because if you differentiate this, this will go to the denominator, you'll differentiate the top, yeah. So 1 over m outside and with a plus c. So just remember this basic rule here, okay? So this is just a basic rule to remember. That will be handy. Only if there's a coefficient here in the front, then we will put a coefficient there. Now, let us decompose this. For obviously, we need to go and factor the denominator. So we can say x plus 5. If we factor the denominator, that will be x minus x plus 2 into x minus 1. You can see plus 2 minus 1 gives us plus x. Yes, Farooq, this will decompose into. This will decompose into a over
x plus a over x plus 2
plus b over
x minus
x
1.
minus. Good, excellent. And we're going to write this equation out, x plus 5. Let's call this the integral, okay? Because I don't want to keep on writing the same thing. So x plus 5 is now identical to a into x minus 1 plus b into x plus 2. So if we try solving this, we will get x plus 5. If x is equal to -2, b falls out. Why b falls out? Because -2 plus 2 is 0. All right, so -2, that will give us 3 is equal to -3a. So a is equal to -1. Now, if x is equal to 1, a falls out. 1 plus 5 is 6. And 6 is now equals to, okay, let's write it next to each other. This implies if x is equal to 1, we're getting 6 is equal to a falls out, so that's 3b. This implies b is equal to 2. So we are integrating, so the integral now becomes integral of a is -1 over x plus 2 plus integral b is 2 over x minus 1 dx. And this is very simple because this is len form. That's negative len absolute value x plus 2, right? Plus 2 len absolute value x minus 1. Absolute value x minus 1 plus a c. Negative len x plus 2 plus 2 len absolute value x minus 1 plus c. Are we good, guys? Are we good, Paru? You understood this? Easy. You can go and combine this. You can go and combine this into a single log. So you can also write this out as len. Obviously, this will be on the numerator. So you have x minus 1 all squared divided by x plus 2. Obviously, absolute value like that plus a c. You can also write it out like this, okay? Remember, there's restrictions. X cannot be equal to -2. X cannot be equal to 1. That restrictions you should have figured it out from here, right? From the denominator in the original problem. Right, so that's your answer. And the absolute value still needs to remain there. So yeah, so we're good enough. So we're taking positive here, positive there. So this is all good. The 2 goes to the front, the negative goes down. Right, let's move on to the next question. Right, so the next question I have like a cubic form. Remember, you can use a calculator to factorize this as well, right? Cubic forms and stuff. Right, next problem I have is this. So I want to decompose this fraction. Before I decompose, I need to factor this out, right? So the denominator part is equal to, the denominator is 2x. I'm trying to factorize the denominator, factor out the denominator, so I can take out x as a common factor. I'm left with 2x squared plus 3x minus 2. I want to check if I can factor this out further. So that's x. Obviously, 2x times x will give me 2x squared. Yeah, it should. 2 times 2 is 4. So plus 4 minus 1. Plus 4 minus 1 will give me plus 3. You can use the calculator to factor this out, right? 2x squared plus 3x minus 2. If you go to mode 5, 3, put 2, the 3, and the -2, you see you're getting half. So the 2 goes there, 2x minus 1, and x plus 2. So great. So we're going to say x squared plus 2x minus 1 over this entire thing here, which is x into 2x minus 1 into x plus 2 is now equals to a over x. These are all linear factors, no repeated. Plus b over 2x minus 1 plus c over x plus 2. Okay, Farouk, we good? So now x squared plus 2x minus 1 is now identical to a into 2x minus 1 into x plus 2 plus bx into x plus 2, right? Yeah, you're not supposed to put that one, but the other two, right? Plus cx into 2x minus 1. Let me see if that is correct. The other two, leave this out, x into x plus 2, leave the x plus 2 out, x into 2x minus 1, yes. Now, if x is equal to 0, then b falls out, c falls out, right? Uh, for x is equal to 0, that's -1. X is 0, so that's -2a. This implies a is equal to a half. See how easy the equations become, right? That's basically partial fractions. So that becomes a half. How 0, 0, -2a equals -1. That's 0, that's 0. So if next one is if x is equal to a half. If x is equal to a half, a falls out, c falls out. But now you got to substitute here. 2 times half is 1. 1 minus 1 is 0. 2 times half is 1. 1 minus 1 is 0. Half squared is quarter. So quarter on the left-hand side equals what we said. B falls out. No, A falls out, C falls out, because if it's half, that's going to give me a 0 there and a 0 there. So half B, and this is 5 over, this is B times half times 2 plus a half is 5 over 2, right? So this implies, see what this equation simplifies to now. So if I multiply both sides of the equation by 4, the 2 and the 2, remember this side is 5 over 4b, okay? So 1 is equal to 5b. This implies b is equal to 1/5. And if last one is if x is equal to -2. If x is equal to -2, A falls out, B falls out. If x is equal to -2, that is 4. 4 minus 4 is 0, right? So that part is out. 2 squared is 4, minus 4 is 0, so that's just -1. And see how easily everything works out, okay? If x is equal to -2, so that is a 0, that's a 0. If that is a -2, that's minus 2c into -5. So this implies I'm getting -1 is equal to 10c. This implies c is now equals to -1 over 10. Right, great. So we are basically integrating this. Right, so the integral is now equals to the integral is basically equals to all of this, right? So I will write down the answer. This is just a ln x plus b ln 2x minus 1. Be careful. B ln 2x minus 1 times a half. See there. Remember, that's a rule that I did at the beginning. Times a half plus c ln absolute value x plus 2 plus another constant k for now. All right, so what was the value of a? A was half. So half ln absolute value of x. What was the value for b? 1/5. But 1/5 times a half is 1/10. And the value for c is -1 over 10. So that's -1 over 10 ln x plus 2 plus, now you can put a constant k, change the k into a c. I didn't want to mix up this c with that c. Okay, let's make it c2. Okay, and that's my final answer. Are we good, Farouk? You understood everything?
Yes, sir.
Right. Quite simple because you understood partial fraction from the previous lesson. That's why it's easy now. And you know exactly where these values A, B, C's are coming from. I'm just doing one example of this linear repeated, right? So let's see if you can solve this. The whole idea is your rules. If you don't know your rules, then you can't really do partial fractions. You got to know your basic rules. So this is the integral. So now this is the denominator is already factored out. So there's nothing for me to do there. All I need to do is just expand the partial fraction x minus 1 all cubed into x plus 2. And that's equivalent to a over, you want to do this one? A over?
Yeah, it will be like x minus 1, so you remain it, then plus b over x minus 1 square, if I'm right. Yeah, and then c over x minus 3 cube.
And plus,
Minus 1, yeah.
and what about the x plus
Plus
2?
1 over
D.
d over
D.
x plus 2.
Excellent. Very good. And now this here is equivalent to, let me move this a little bit more towards the side. We might need to solve simultaneous equations here. Let's check. So what we have here is x squared plus 1 is now identical to a over x minus 1. You need to take out one x minus 1. So you're left with x minus 1 squared into x plus 1. How are we getting x minus 1 squared? Remember, you take this LCD here and you need to divide it by x minus 1. So one x minus 1, one x minus 1 disappears. So you're left with the balance plus b into x minus 1 squared, x minus 1 squared disappears. So you're still left with one more x minus 1 into x plus 2. X minus 1 cubed, x minus 1 cubed disappears. You're just left with c into x plus 2. X plus 2 disappears. You're left with plus d into x minus 1 all cubed. Right, so there's lots of variables here to solve, but let's see if we can solve it. Uh, let me not write if, right? So let's say if x is equal to, if x is equal to 1, If x is equal to 1, A disappears, B disappears, D disappears. We can solve for C. So 2 is equal to 3C. This implies C is equal to 2/3. If x is equal to -2, A disappears, B disappears, C disappears. We can solve for D if x is equal to -2. If x is equal to -2, that's going to give me 5. That is out. -2 will be 27D. Why? Because that's -2. -3 cubed is -27D. So the value of D is -5 over 27. All right, quite complicated, but not difficult. Now, remember to solve for the rest, you gotta use different values because we can't really solve for other factors. So for A and B, just choose x is 0. See, I didn't use 0. So if x is equal to 0, that is 1 on this side. If I choose 0, so that is 2A. If I choose 0 here, minus 2B. If I choose 0 here, plus 2C. If I choose 0 here, if I choose 0 here, it's -D, right? Uh, so 2C -D. So I can write down an equation here. Okay, let me, because we might need to solve simultaneous equations. So let me write this. If x is equal to 0, here, let's structure it out like this because we won't be able to solve uh, because we got two unknowns. So 2C minus D. I want to find the value of 2C minus D, 2 times C minus D. So mode 1, 2 times C. What is C? 2/3, right? Minus D is minus 5 over 27. Okay, so that answer I'm getting is 41 over 27, and I need to take 1 and minus 41 over 27. So 1 minus the answer because I need to take this to the other side. So I'm getting an answer which is -14 over 27. -14 over 27 is equal to 2A plus 2A minus 2B. Now, if x is equal to, choose a easier number now. If I already chose 1, so let me choose if x is equal to -1. If I choose -1, it's going to give me 2, or 2 on this side. This is the second simultaneous equation I'm doing, all right? It's going to give me 2 on this side. Remember, I'm choosing -1. So -1 squared. That's going to give me 4A, just 4A, -1. -1 plus 2 is 1. So -2B. What we have here is
-C just, I think.
uh, not -C, just C, because -1, yeah, it's just going to be plus C, and that's -1. So -1, -1 is -2 cubed is 8. So -8D, right? So I need to simplify this equation as well. So I'm going to say, I want to find out what's the value of C minus 8D now, right? And then take 2 minus the answer. So C is 2/3 minus 2/3 minus 8 times D minus 5 over 27, right? So I've got an answer of 58 over 27. So 2 minus 58 over 27. I'm getting -4 over 27, right? Which is 4A minus 2B. What we can do is we can multiply the first equation by -2, so make it positive. So 14 over 27 is equal to -2A plus 2B. Right, so I've got a positive here. I multiply the entire equation by negative, so I've got a positive here. And what do you have here? You can take that equation and put it under that and add them up. add up equation 1 and 2, right? So sometimes you've got to solve a simultaneous equation. So this is minus 4 over 27 is equal to 4a minus 2b. So now I want to add up both these equations and see what I get. So if I add up both the equation, the two b's cancel out. So I'm getting 2a, and on this side, I'm getting 10 over 27, right? If I add them up. So this implies the value of a is 5 over 27 because divide both sides by 2. If the value of a is 5 over 27, then we can solve for the value of b. How can I solve for the value of b? Look at this equation here. I'm going to take 2b to the other side. So you need to come back and solve for the value of b. So I'm basically substituting this answer inside here. How? Take the 2b over. I'll bring this 4 over 27 over. So 4a plus 4 over 27. Divide everything by 2. So you got 2a plus 2 out of 27. But what's the value of a? 5 out of 27, okay? So 2 times 5 out of 27 is 10 out of 27 plus 2 out of 27. So I'm getting 12 out of 27. I think 12 out of 27 divided by 3, divide by 3, you get 4 out of 9. Check. 12 divided by 27 is 4 out of 9. Yeah. All right. So we are basically integrating something like this. Okay. So the integral is now equals to all of this. Now we want to know what we can integrate and what we need to leave out. So I can integrate a and d because that's in len form, but these are not in len form. So I'm going to integrate this and this. So I'm going to say a len absolute value x minus 1 plus d len absolute value x plus 2 plus integral of b over integral of b over x minus 1. But now how are you going to write b over x minus 1? That's not in len form. That's in u substitution form. So b x minus 1 to the power negative 2 dx plus c b and c plus integral c into x minus 1 to the power negative 3 dx. We have to use u substitution here, okay? What was the value of a? The value of a is 5 over 27. So these two can be done. Right, so the answer is 5 out of 27. Okay, wait. Now let me go and integrate the third and the fourth integral, all right? Call it integral I3 and integral I4. So we're going to say let u equal to x minus 1. This implies du is equal to dx. Right? So du is equal to dx. So the integral I3 now becomes integral of b u to the power negative 2. Okay? du. Integral I4 now becomes, okay, you don't need to just call the whole thing integral I3 because it's the same u substitution. And this one will become, wait a minute, you can use the same substitution. You don't need to go and split them up. So because b plus c u to the power negative 3 dx. The whole integral can just be the second integral, not really integral I3. It's fine. I3 and I4, we can just combine those and make it like that, right? Now, what's the integral of this? This is power form, right? So that's b u to the power negative 1 over negative 1 plus c u to the power negative 2 over negative 2 plus c plus some other constant k. So this will become negative b over u. What is u? U is x minus 1. This is negative, so negative c over 2. And this u minus 2 will remain in the denominator. So that will become x minus 1 squared plus k. So my final answer, the integral total is A. What was the value of A? 5 out of 27 ln x minus 1 plus what was D? D was minus 5 out of 27. D was minus 5 out of 27 ln x plus 2. The value for B was 4 out of 9, so minus 4 out of 9 x minus 1. Value for C was 2/3, but now you have 2/3 divided by 2, so 1/3. Plus, remember you got 2/3 divided by 2. 2/3 divided by 2 is 1/3, okay? And this is your final answer for a problem like this, okay? But I doubt you will get so many decomposition. Maybe they just put a square there, so it'll be much more easier to solve if it was a square instead of a cube. But you saw the reason why I did this problem is to show you that you can't avoid simultaneous equations here, right? So you can come across simultaneous equations in decomposition of partial fractions. Great. Now let's look at the next one. Now the thing about quadratic factors is we got to use some kind of a rule, all right? And the rule to use here is, I don't like to use this rule because I want to prove it first and then apply the rule, all right? No use learning rules. You got to know how that result came about. So, okay, first, you see the integral of 1 over x squared plus a squared dx is 1 over a arctan x over a plus c. How? How is that possible? Well, I'll show you exactly how that is possible, right? I'm going to do the integral on this side. You remember the rule that we have learned is, obviously this is arctan form, right? So the integral of 1 over x squared plus a squared dx, because we got to complete the square here, right? Integral of, take out a squared as a common factor. Yeah, we're supposed to be completing the square and then taking du dx. So remember x squared plus a squared, x squared plus a squared is now equals to a squared into x squared over a squared plus 1. And so now it's in the arctan form. Remember, this is a squared into x over a all squared plus 1. Okay? So that's the reason why we say let u equal to x over a. So du is now equal to 1 over a dx. Right, so this integral result, I'm putting result of the integral result. That R means the result of the integral. Right, so the integral result will now be equal. Remember, this entire part over here in the denominator is replaced with this, okay? Now remember what I said dx was. Dx is a du. And what's the denominator? Is u squared plus 1. Remember, you still got an a squared out. This is a squared, right? I'm just substituting here. That's u squared plus 1. So 1a over here, 1a here cancels out. Now the integral of this is 1 over a. That 1 over a is just there. Integral of 1 over u squared plus 1 is arctan u, or tan inverse u plus c. And what is u? X over a. Okay, so that's where the result over here is coming from, okay? 1 over a arctan x over a plus c, if you get something like this in this form. So let's look at this part over here and decompose. So we can say x squared plus 1 Farooq, you want to decompose this? X squared plus 9.
Yeah, please. It will be like a over x squared plus 9, yeah? If or we should,
No, no,
oh
no, no,
wait,
no.
we should
Quadratic
make
factor.
them product factor, yeah. It will be like ax plus b, yeah?
Very good. And then,
And then just c over x plus 2.
very good, because that's linear. Nice. Right, so now let's simplify everything here. I'm calling this the integral. Right, so let's see. So we're getting x squared plus 1 is equal to ax plus b into x plus 2 plus c into x squared plus 9. Now, let's solve for ABC. If x is equal to -2, a and b falls out. So I'm getting 5 on this side by substitution. If x is equal to -2, we said a and b falls out, right? So -2 squared is 13c. This implies c is equal to 5 out of 13. If x is equal to 0, what falls out? If x is equal to 0, nothing falls out, so just 1. A falls out. That's great. So that is 0. B times 2b plus 9c. So we can solve for b, all right? B is equal to 1 minus 9c divided by 2.
10c you said, no? 10c should be. Oh,
No,
yeah, wait.
9c. X is 0.
0 to the power of 2, yeah, right, sorry.
1 minus 9c divided by 2. But we always solve for c, okay? So we can get a value for b. I'm just going to put it in the calculator. 1 minus 9c divided by 2. 1 minus 9 times c. C is 5 out of 13. And dividing it by 2. We're getting -16 over 13, all right? All right, and now to solve for a, we can choose any value, all right? Let's just choose the value of x equals 1. 1 plus 1 is 2. A plus b into, remember we're substituting 1. Okay, so you should have said 3a plus 3b because we solve for bc, we're just solving for a now. So that is, a is 1. So a plus b times 3. So 3a plus 3b. That is 1. So 10c over here. That is 10c. What are we solving for? We got b and c. We're solving for a. So the value for a will be 2 minus 3b minus 10c divided by 3. So 2 minus 3 times, what's b? -16 over 13 minus 10 times c was 5 out of 13. All right, and I'm going to divide it by 3. So I've got 8 out of 13. Okay. And now this is the thing that I need to integrate, okay? Right, so it's easy to integrate the second part. That is just c ln x plus 2 plus, the problem is to integrate this ax plus b over x squared plus 9 dx. How are we going to integrate this? Right, so to integrate this part, over here, call it integral I2 we're going to split this up. So we're going to split this up as ax over x squared plus 9 plus integral b over x squared plus 9. But now, this one here we can integrate easily, okay? Why? Because we can apply this rule here. We can apply the arctan rule, okay? Okay,
But before
so
applying, we should make the 9 like 3 square, yeah?
yeah. So basically your 9 is like your 3 squared, that's correct. You can see it straight from here. That's the reason why I didn't bother doing that. I thought you already know that, okay? Yeah, so your 9 is basically your 3 squared. So this is your rule that we're going to apply, right? So this part is also sorted out. And then this part will just become u sub, okay? So how come it's u substitution? Very simple. Let u equal to x squared plus 9 was du equals to 2x dx, okay? So integral I2 now becomes integral. What is x dx? X dx, we can see here in the integral. X dx is du over 2. The a remains there, and this bottom becomes u. Right, so this is half a. We can integrate this ln absolute value of u. We forgot to integrate this part. This part is sorted. This here is basically equals to 1 over 3 arctan or tan inverse x over 3 plus a k. Right, so we have integrated this now. I'm still busy integrating this. This is half a ln, what's the absolute value of u? X squared plus 9. Now you can drop the absolute value because you know that this result is always positive, right? Plus C2 plus C2. Okay, now we're going to collect all the results and put them together. Right, so my total integral is this. My integral total is now equals to, what was this? C. What is C? C was 5 out of 13 ln x plus 2. Uh, let's put the a as well. Let's put this integral also, and we'll put that arctan last. Half a, what is half a? Half a will be half into 8 over 13. Half of 8 is 4, so 4 over 13. So plus 4 over 13 ln x squared plus 9. And what was the last part? The last part is just 1/3 tan inverse, right? So plus 1/3 tan inverse x over 3 plus a c. Are we good? Understand everything? So you can see we applying partial fraction, then we're going back to the previous techniques of integrating using uh, square root forms and, you know, identifying the forms of ln and arctan, inverse trig forms, and putting the answers together. Okay. So imagine a simple question like this becomes so complicated with arctan and ln. All right, so next problem. Right, so now is basic stuff, just long division and stuff that we need to work with. All right, I'm sure it'll be easy for you. All right, so long division is, you know, the degree on the numerator is bigger than the degree in the denominator. You always need to apply long division. All right, if you try to factor them out, nothing will cancel out, so it's not going to help. So we're going to apply long division. You say x cubed plus x divided by x minus 1 is equal to, so is equal to what? Now you can do the synthetic one, right? Uh, remember you were asking me about synthetic, so there you can do synthetic division because it's in the because you have a linear factor in the denominator, so you're gonna put a one outside, okay? Make sense? Put a one outside, and this is one, the detached coefficient 1, 0, 1, 0. So what do we do first? We bring down the one, we multiply and add, right? So 1 times 1 is 1, add them up, you get 1. And then this 1 times 1 is 1. You add them up, you get 2. Okay? Make sense so far? And then 1 times 2 is 2. You add them up, you get 2. So the last value is your remainder. Okay? So what's the equation for what's the answer for this? This is x squared, because you got a polynomial here with 3 terms, x squared plus x plus 2 plus 2 over the divisor, which is x minus 1. And it's easy to integrate this, okay? The integral of that will be equal to integral of x squared plus x plus 2 plus 2 over x minus 1. That's x cubed over 3 plus x squared over 2 plus 2x plus 2 len absolute value x minus 1 plus c. You understand? Now, let me do the long division for you because we have done synthetic here, all right? Okay, Farooq? We have done synthetic, we got an answer. Because I remember you were asking me about synthetic division in the previous lecture. Right,
Yeah.
so now let me do long division here now. The long division is like this. What's in the denominator? 1, negative 1. What's here? 1, 0, 1, 0. Right. So 1 can go into 1 times. 1 times 1 is 1. 1 times negative 1 is negative 1. Subtract, get 1. 0 minus minus dot. Bring down the 1. 1 can go into 1 times. 1 times 1 is 1. 1 times negative 1 is negative 1. Again, subtract 0. That's 2. Bring down the 0. 1 can go into 2 times. 2 times 1 is 2. 2 times negative 1 is negative 2. Get the same answer, 2. So remainder is 2, and there's your quotient. Okay? And it's exactly the same as this one here. Why it works? Because it's a linear factor in the denominator. You can only do synthetic if it's linear in the denominator. If it's quadratic and stuff, you can't do synthetic. Right? Like in the when can't you do synthetic is in this case. See, it's like a quadratic here. Then you can't do synthetic here, okay? You're taking that and you're fine with this. Anyways, let's continue. So that's my answer. Answer is done. Let's move on to the next problem. Yeah, I do have examples that where you can't do synthetic, like this case. Right, so first we see that the degree on the numerator is clearly bigger than the degree in the denominator. So we gotta apply long division. Right? And obviously the answer needs to be x plus something, right? So what's here? Let's call this the integral. So you're gonna have 1. There's 4 terms, right? So minus 1, minus 1, 1. And there are 5 terms here. So that's 1, 0. There's no x cubed. Be careful. That's minus 2, 4, and 1. 1, 0, minus 2, 4, 1. 1 can go into 1 times. 1 times 1 is 1. 1 times minus 1 is minus 1. 1 times minus 1 is minus 1. 1 times 1 is 1. Right, we're going to subtract. That's 1. Subtract those two. Minus 2 plus 1 is minus 1. 4 minus 1 is 3. Putting down the 1. These numbers one can go into 1. Do we stop here or do we continue? we need to look at these factors. Can this go into this? 1 second, 0 minus 1 is 1, minus 2 minus 1 is minus 1. No, I think we can go one more time. 1 can go into 1, 1 times 1 times 1 is 1, 1 times minus 1 is minus 1, minus 1, and 1. Yep, 0, 0, 3 minus minus 1, that's 4, and that is 0. Now you can stop. So your answer for this, your decomposition for this, x to the power 4, basically this part is now equivalent to the quotient plus the remainder, okay? The quotient is x plus 1, right? And the remainder is 4 over this entire cubic, which is x cubed minus x squared minus x plus 1. But now, remember, this part is done. We can't integrate this because now this part here is basically a partial fraction, right? So we need to have a look at this part and see if you can decompose this further. So we have to check if we can decompose this a bit further. Now, how can we decompose this a bit further? By factorizing the denominator. So the denominator part is now equal. I need to factorize the denominator first. So I have x cubed minus x squared minus x plus 1. I can see that I can take out x squared from the first two terms, right? And I can change of sign, x minus 1. So now that becomes x squared. X minus 1 can come out as a common factor. We're left with x squared minus 1. We can do dots here. That's x minus 1, x minus 1, x plus 1. And guess what? That's x minus 1 squared into x plus 1. So this is basically 4 over x minus 1 squared into x plus 1. That's why it's very important to factor it out first. If you don't factor it out, then how are you going to know what to do? So let me take this part out. Right, so this part is equivalent to this. Right, so is there a way to do it on the calculator? Yes, there is, but how are you going to know which one is repeated? Or let's use a calculator to check, to factor the same thing out. X cubed minus x squared minus x plus 1. Right, so obviously I need to have 3 brackets, 1, 2, 3. So let's check on the calculator mode 5, option number 4. So you got 1, minus 1, minus 1, and 1. 1, minus 1, minus 1, and 1, right? So I'm getting x1, which is minus 1. So that becomes x plus 1. And then I'm getting x2, which is minus 1. And then I only had 2 answers. But remember, you got 2 factors. So obviously the third one has to be x, because x times x times x is x cubed. And then 1 times minus 1 is minus 1. So obviously the last one has to be minus 1, because I need the positive result at the end, okay? By multiplying out all the numbers at the end. That's how you double check. Right, so I can use a calculator, which is much more easier. So this is the same thing as saying x minus 1 squared into x plus 1. Right, so you have to factorize it completely in order to do. So the rule is x over x minus 1 plus b over x minus 1 squared, because it repeated, plus c over x plus 1. Now, let's simplify. That's going to give me 4 is identical to a over x minus 1, x plus 1, plus b into plus x minus 1 squared, so x plus 1, plus c into x plus 1 cancel out. You're left with x minus 1 squared. Now substitute values to solve for a, b, c. If x is equal to 1, what falls out? A falls out, c falls out. So you're solving for b. 2b. This implies b is equal to 2. If x is equal to -1, a falls out, b falls out. So 4 is equal to 4c. So c is equal to 1. If x is equal to 0, because I already exhausted all my values to choose, so I'm choosing the third value, which is random. 0. If x is equal to 0, so I've got 4 is equal to -a plus b plus c. And so what am I solving for here? I'm solving for a here, right? So take the a over, right, and bring the b over. So b plus c is 3. If I take the a over, so I've got b plus c minus 4. So the value of what's b plus c? 3. 3 minus 4 is -1. Right, so now my integral is equal to, what am I integrating? I'm integrating this part. Those two is I'm going to put here. All right, plus I'm integrating all this. So integrate whatever you can and leave out the balance of the integral, right? So I can integrate x plus 1, which is x squared over 2 plus x. I can integrate a and c. A ln x minus 1 plus c ln x plus 1. Plus integral of b over x minus 1 squared dx. But you already know this. This is like du is equal to dx. Let u equal to x minus 1. Du is equal to dx. So you are rewriting this integral like this. Bu to the power minus 2. Right. So x squared. Okay, I'm gonna solve that side of the integral first, and then I'll write down the total answer, right? So this is now equals to integral bu to the power -2 du, which is b over u, bu to the power -1 over -1 plus c. So that's negative b over u, negative b over u plus, just call it c1. All right. So my final answer, you know what the value of u is. That's x minus 1. All right, so now let's substitute everything inside now. X squared over 2 plus x. What was the value of a? A was -1, negative ln. What was the value for c? C was 1, so ln. And remember, all that is part of that integrals. So minus b over x minus 1. What was the value for b? B was 2, minus 2 over. How did we go to your understanding? It's easier, right? Doesn't look bad.
Yes, sir, Hansen.
Yeah, it's not difficult at all. It's just a matter of identifying the partial fraction, applying the rule, and then solving. Minus 2 over, right? And plus c. And that's your final answer. This one here. Right. Remember, I'm not combining anything here. If you're going to try to combine the two lens together, you can do that. When you combine this lens together, so it's going to say plus len, x plus 1 will go up, and x minus 1 will go at the bottom because of the minus. Okay, and that's the answer. All right, so one more example here. Now over here, how do you know whether this is long division or not? Because look at the powers. The powers are the same, but remember what you said, the degree on top must be bigger than the degree at the bottom, but now that's not the case. So you need to move on to the next one. Which one is bigger, -3 or -4? Hmm? Which one is
Minus 3,
bigger?
of course. Minus
Yeah,
3.
so -3 is bigger. So that's the reason why we say the top is bigger. If the top is bigger than the bottom, then it's improper, okay? Not as in improper integer, it's just basically a improper fraction. So it's more like top is bigger. Numerator is bigger than the denominator, basically. So that's the reason why we can do long division. Numerator is bigger than the denominator. So we're going to apply long division again. Let's apply long division here. The top is 4, -3, and 2. The bottom is 4, -4, and 3. 4 can go into 4 one time. 1 times 4 is 4. 1 times -4 is -4. 1 times 3 is 3. We subtract. -3 plus 4 is 1. 2 minus 3 is -1. And you stop. So your long division problem is this now. So this part is basically equals to 1 plus x minus 1 over the divisor, which is 4x squared minus 4x plus 3. Now we want to check if this is a partial fraction. 4x squared minus 4x plus 3 mod 5, 3. So 4 minus 4 and 3. Aha. So you need to complete the square because we are not getting rational roots or rational zeros. In other words, we find that the b squared minus 4ac is negative. So we need to complete the square here to check what substitution to choose here, right? Yeah. So we need to say 4x squared minus 4x plus 3. Now we can remember it's not a square root form. It's basically one of the forms of remember we have done something like this in uh, integration techniques when you're doing inverse trig. So you're basically looking at something like this. See, it's in this form, 1 over 1 plus x squared. You need to put it into this form. Okay, so let's go back and put this into this form. So you got to complete the square. Take out 4 as a common factor first. I'm left with x squared minus x plus 3/4, right? Now x squared minus x plus 3/4, right? So we need to complete the square. So this one over here, divide by 2 and we square it, coefficient of x. So x squared minus x plus something squared minus something squared plus 3/4. Now what is that plus something and the minus something? Is basically the coefficient of x and we're squaring it, minus half, right? You take the coefficient of x, you divide by 2 and you square it. So we're getting 4 into something squared. So that's x. What's the value of this? Minus half squared. This is minus quarter plus 3/4 is 2/4, which is basically I'll leave it as 2/4 for now because we need to take the 4 back inside. So now when you multiply the 4 inside here, okay, wait a minute. You don't need to multiply the 4 inside here. 1 second. Yeah, we need to take the 4 back inside. So 4 into x minus a half squared plus a 2. 4 into x minus half all squared plus 2. All right, so now we got 4 into x minus half all squared plus 2. I want to put the 4 back inside the square, right? If I want to put the 4 back inside the square, I'm going to take it as 2, right? See, if I have 4 times a squared, it's the same thing as saying put the 4 back inside, square root it. So it becomes 2a all squared, okay? So that's the logic that I'm using here. So we got to know like the basic logic in order to put it into that form, right? So, but I wanted a 1 here. Okay, so I see where the problem is. We need to make the 2 into a 1, right? Because remember, when you're completing the square, no, okay, we can use that other formula. Okay, so it's fine. You can take the 4 back inside. Now, if you're taking the 4 inside, it's going to become 2x, and then 2 times minus half, something like this. Not like that, with the square outside. Like that. All right, so 2 times x is 2x minus 1 all squared plus 2. So now I have the form a squared plus b squared. See, I got a squared plus, right? I have that form. You know the form of the arctan? Arctan form, where is it? There's it here. Proved it to you. There's the arctan form. See, x squared plus a squared. So now I'm going to use, so let's see what we have. Let's see our development so far. So far what we have is this part over here. Right? So just want to neaten this fraction up. Because remember, I'm trying to find the integral of this fraction. So what was the fraction? X minus 1. And it was easy to integrate 1. Integral of 1 is just x, right? So we're going to say let u equal to 2x minus 1. So du is equal to 2 dx, okay? But now I can't solve this integral. I need to split it up into 2 parts, x over 4x squared minus 4x plus 3 dx. I have a x minus 1 here. X over 4x squared minus 4x plus 3 dx plus integral of negative 1 over 2x minus 1 all squared plus 2. Okay? Dx, that's what I have so far. But remember, the 2 can be written as root 2 squared. Just remember that. Okay, so du is equal to 2 dx. So basically, I'm solving this part of the integral, right? For that. So that's integral of negative 1 du. What is dx? Du over 2. And what am I left with here? That's basically u squared plus root 2 squared. I'm just converting the 2 into root 2 squared. So now you know this is arctan form. What's the arctan form? 1 over root 2 arc tan. Remember, you're going to have that negative half. I can just take it out, okay? This negative half is just out of the integral. So I'll write that at the end. So let me see what this is. Arctan u over root 2, right? Times negative half plus c. Right, so that's negative 1 over 2 root 2 tan inverse. What is u? U was 2x minus 1. Now, what about solving this part of the integral? Having a problem with solving this part of the integral, x over 2x minus 1 whole squared plus 2. Isn't we supposed to be using a u substitution here? But let's try u substitution here, okay? Because we got an x on top. So let u equals to 4x squared minus 4x plus 3. Remember, this is the first, this integral is solved, okay? Trying to solve this now. So du is equal to 8x minus 4 dx. Du is equal to 8x minus 4 dx. But we don't have 8x minus 4. How can convert this to make it 8x minus 4? If I put 8 here, how can I get 8x minus 4? Which means that I need to minus 4, I need to add 4. So minus 4, add 4, all right? And then I need to multiply it by 8 to get 8, no. I need 8x minus 4, which means that if I take out 8 as a common factor, that's x minus half dx, which means that I need to minus half and add half. 1 second. If I minus half, add half. And then if I multiply it by 8 over 8, that's how I'm going to get 8x minus 4. So which means that I'm going to group these two up and I will get 8x minus 4. So that integral is basically 8 into x minus, I'm going to leave the 1 over 8 here. Take the 8 inside over here now. So 8 into x minus a half, right? Plus a half dx over 4x squared minus 4x plus 3. So we got a problem because we still got that other half over here. So what I'm going to do is, remember this 8, I took it into the first part, I didn't take it into the second part. So it should be not minus half, should be plus 4. So I'm basically multiplying the 8 inside. So it should be 8x minus 4 plus 4. We still got the 1 over 8 lying outside. So you see this part of the integral is fine. Okay, this part of the integral is fine because that's just 1 over u, right? 8x minus 4 with the 1 over 8 outside. So this
Okay,
is
I have one
basically 1
question.
over, Yes.
We can make it like plus 4 over 4x squared minus 4x plus 3 in the different integral. We can make two
This,
integrals. In one part it will be 8x
yeah,
minus
yeah,
4 divided by 4x
yeah,
like
yeah, yeah,
this.
yeah, yeah. Yeah, that's what we're doing. We're making it into two separate integrals. I didn't come to that part as yet. That is correct. So that's 8x minus 4 over 4x squared minus 4x plus 3. So this is 1 over 8. This is just len form, len absolute value. 4x squared minus 4x plus 3 plus 1 over 8 integral 4 over 4x squared minus 4x plus 3 dx. But you see, the second part, 4 over, right? The second part is just arctan form. Is this entire part over here? Because remember, when we had a negative 1 here, we had a 2 there. This entire thing is of this form here. So 1 over 8 times 4 is half on top. Okay, this part remains put. This part is fine on this side, right? But remember, this side we can also write it as 1 over 8 len. This is always positive, so drop the absolute value. 4x squared minus 4x plus 3. And this part over here is plus half. What is this denominator? This denominator is exactly the same as this denominator here. Right, those two denominators are exactly the same. All right, so dx. So remember before what we had minus 1 and we got a half. So if this is a half here, we had a minus 1. So remember I said must combine the minus 1 and the 2. So over here in this case, what you're going to do is for this part of the integral, we kind of going back to this form here because we're going to have the exact same u substitution. So you're not going to have a minus 1 here, right? You're going to have a positive half, right? So half divided by 2 will be quarter, right? And all this will be just 1 over root 2 tan inverse u. What was u? 2x minus 1 over root 2 plus c2. But look, I should have just went and started integrating this part here first by using a u substitution. I'll show you how to do that. So my final answer would have been, because see, this part over here split up into half, and then half minus 1 is minus half. Half minus 1 is a minus half. So I would have had a minus half here. Yeah, so my final answer would have been, remember, we need to go back to the original now. Integrate the 1, you get x. Okay? Plus integral of, I'll rewrite it, x minus 1 over, we had x minus 1 over 4x squared minus 4x plus 3. So what I'm saying is, we should have actually rather modified this part instead of going and doing all this. Right, so anyways, we got x plus, you remember when we split this up into two parts, this part gave us, oh yeah, you remember when we split this up, we split it up into this part, 1 over 8 len, 1 over 8 len 4x squared minus 4x plus 3, right? So this part over here was basically 1 over 8 ln absolute value 4x squared minus 4x plus 3. Actually, we said we can drop the absolute value because it's always positive, right? And then remember this x part over here. Oh, yeah. Remember this x part over here split up into two integrals, which was half over all of this plus half over 4x squared minus 4x plus 3 dx. We had plus half, and this part over here was minus 1. So we can say minus 1 plus half and then minus 1. So we can combine this result. So x plus 1 over 8 ln 4x squared minus 4x plus 3. So you shouldn't have, initially, I shouldn't have went and split this up into two parts. I should have just worked with the u substitution and then eventually decide that which part will be left over. That's what I'm trying to do here. Plus half minus 1 is negative half. Integral 1 over, this is square root form, you got to do that. So there's 2x minus 1 all squared plus root 2 squared dx. All right, so remember what we said for this part. This part is all of this, right? Right? This part is all of this. And then we were going to have negative half over root 2. Remember over here, negative half over 2, actually, because of this. See, that negative 1. Now I've got a negative half there. So I've got negative half, still need to divide it by 2. That's what I'm doing here. Plus a c. So my final answer implies is x plus 1 over 8 ln 4x squared minus 4x plus 3 minus half, that'll be minus quarter, 1 over 4 root 2, tan inverse, what's x? That's 2x minus 1 all squared, root 2. Sorry. That's 2x minus 1 over root 2 plus c. And that should be your final answer. Okay. So I would suggest just try to integrate this by making this denominator equal to u and then modifying it like this. In this case, then you'll get a total sum at the end. Right, Farooq? We good? And then the
Yep.
last example, last example, last example. All right, so I have something like this of this form, right? Right, so first, what we're going to do is make the square root disappear, right? So we're going to say let u equal to x plus 4. So du is equal to dx. Will that help us? Let's see. What is dx? Du, that's root u over what is x? We modified this. What's x? X is u minus 4. Okay. X is equal to u minus 4. Mm, will that will this help us? No, this u substitution is no good because see, I didn't end up with anything. So I would say let u equal to the whole thing, square root of x plus 4, right? So this u substitution not helping us. Yeah, this u substitution not helping us. So we'll take this out. Let's say let u equal to square root of x plus 4, right? So I'm going to square both sides. So say u squared is equal to x plus 4. Now I'm going to differentiate both sides, okay? So 2u du is equal to 1 dx. Right, so there's your equation 1 and there's your equation 2. Now, so this integral now becomes, what is square root of x plus 4? U. What is x? X is equal to u squared minus 4. And what is dx? Dx is 2u du. So what do we have? Integral of 2u squared over u squared minus 4 du. Okay? Now we can clearly see that the top is bigger than the denominator. All right? So we need to apply long division here. But take the 2 out. I suggest take the 2 out, right? So let's just work with u squared over u squared minus 4. So u squared will be 1, 0, 0. U squared minus 4 will be 1, 0, negative 4. Ah, okay, okay. You don't need to do this. There are tricks in simplifying, okay? So I took the 2 out. So tricks in simplifying is minus 4, add 4. Okay, if you minus 4 and if you add 4, they can split it up into two different integrals, one here and one there. Don't forget the 2 outside. So this is now equals to 2 integral u squared minus 4 over u squared minus 4 du plus 2 integral 4 over u squared minus 4 du. That's easy, that's 1, all right? Now let's solve this part. Now this part is a partial fraction because that is 4 over, this is 4 over u plus 2 u minus 2, which is a over u plus 2 plus b over u minus 2. So that will give us 4 is identical to a into u minus 2 plus b into u plus 2. So if u is equal to 2, if u is equal to 2, then a falls out. That's 4b implies b is equal to 1. If u is equal to negative 2, you're getting negative 4a, right? B falls out, so this implies a is equal to negative 1. Now, so the integral of this, we know what the integral of this is now. A ln u plus 2 plus b ln u minus 2 plus c2. Now remember, okay, avoid this c's and stuff because we finished right down that. Remember, we still got to multiply it by 2 here, okay? So my final answer, what's my final answer? So this part implies 2u plus c1. So now my integral answer is, what was the u? We had a different u over here, right? This u was square root of x plus 4. So 2 square root x plus 4. 2a. What is a? Negative 2. Ln And what is b? B is 1, so 2b ln u minus 2 plus c. I forgot to write down, this should be u. What's the value of u? Yeah, that's all that is incorrect. Remember, u was root x plus 4 plus 2 plus 2 ln root x plus 4 minus 2 plus c. Right, I hope you guys understood everything. Yeah, Farooq, we good? Yo,
Yeah,
this
good.
was
So
difficult section.